All right, why don't we get started? Good evening, everyone. My name's Steven Neale. I'm the Borough Administrator in Waldwick, and I'm joined tonight with representatives from H2M Architects and Engineering. That includes Vice President Pat Cole, Practice Leader and Hydrogeologist Karen Benson, and Assistant Vice President Bill Del Nero. So thank you guys for joining us. I believe we're gonna see the mayor was supposed to pop on and say a few words, but maybe we'll find if he gets on a little bit later. I'd also like to recognize and highlight the Water Quality Committee that was recently formed due to these issues, and that includes Mayor Tom Giordano, our Municipal Clerk Kelly Halowitz, our Confidential Assistant Tatiana Marquis, Councilwoman Michelle Weber, Councilman Mark Ramundo, our Community Liaison Michael Goodell, and also our DPW Superintendent and Water Operator, who unfortunately had something come up this evening, so he's not going to be able to join us any longer. So with that being said, if anyone has any questions kind of on the technical aspects of the system, hopefully someone from H2M or myself will try and handle it. If not, we'll take your question and we'll get you an answer as soon as we can. So I just want to make sure, team from H2M, we can all hear each other okay? We're good to go? All right. All right, so before we jump in, I just want to note this meeting is being recorded. It's going to be posted to our YouTube channel and shared out on all of our platforms, including the website, our email blast, social media channels, Facebook, the whole deal. And we'll get that out tomorrow along with the presentation that you're going to see tonight. This is our first session. We are planning to have a second, so this one is virtual only. Our second presentation in the fall is going to be in person and virtual, so it'll be a hybrid meeting. Again, that will also be recorded and shared out on all of our platforms also. Just when it comes time for Q&A, which we're going to hold the main session at the end, but we are going to take pauses throughout the presentation and allow people to kind of digest and ask questions as we go. But please, when it comes time, you just need to raise your virtual hand and we will enable your microphone. We're not going to enable cameras tonight. So you will see something pop up. Just click on mute and you'll be able to talk. We would just ask that you identify yourself. You do not have to give your address, but we do prefer that you give a name. No anonymous here. So if you have any false names or funny names, please change that to a legitimate name. Otherwise, we are not going to allow you to talk. All right. So with that being said, I guess we'll jump right in. So obviously, everyone knows we've been dealing with some issues the past year or so. We've done an awful lot of work to the system. Some of the recent projects we want to go over that we feel has kind of contributed to all the issues that people have been experiencing. Most notably, our PFAS treatment project was completed last year. That actually, planning for that started in, I think, like 2021, 2022 even. That started to get talked about. That project was completed last summer about this time. We received our final approval notice from the DEP, I think actually end of August, September of 2024. It's important to note that over the past 2 years, we've probably spent about $7 to $8 million on water infrastructure improvements. So we've been doing a lot. We haven't just been, sitting around and waiting for things to happen. We've been actively and aggressively attacking the system and trying to get things done. Aside from PFAS, we also recently completed the storage tank rehab project, the two large storage tanks that are located in Wyckoff. Those were completely renovated and rehabbed, cleaning, painting. We actually added some mixers in there too, just to help with clarity issues. So that is back online. Both tanks are online right now. We also installed a couple water main loops. That includes the project that was on Hemlock to Evergreen. That kind of ran through Midland Park also. And we also did completed a loop on Sheridan Ave near Bergen. Those are also completed. So the water main loops eliminated some dead ends, which create some additional issues, including some clarity issues, just help overall flow throughout the system also. More recently, we've actually implemented a system-wide leak detection We just hired that contractor, so that equipment's been ordered and should be getting installed in the next month or so. That's going to really allow us to pick up on very small leaks well before they reach the surface. So we're going to be actively monitoring. That project includes a monthly monitoring system as well. So we'll have eyes and ears, I guess, really all throughout town on the entire system, which is a huge improvement for us. Also, the ongoing lead service line replacement, which we'll get into a little bit later on. That is a requirement from the DEP as well, which I believe Karen's going to go into some detail on. That is ongoing. Some people have received letters of unknown service line material, so we could dive into that a little bit more later. Also, we're aggressive with our annual water main flushing program. We actually started doing the entire town twice annually instead of just going, the whole town once annually. We used to split it up by district, but now we're going full blown the entire town 2 times a year. We started doing that work overnight hours just to limit the disruption to the residents. And that's been working out well also. And then just finally, our general system asset management and equipment repair and replacement. I had some updated numbers just for 2025 to date. Our water department's replaced over 35 valves throughout town. So they're, again, aggressively checking all of our valves and equipment throughout town. So I know there's been a lot of notices, there's been a lot of work and shutdowns, but we're getting a lot done and we're making some big improvements to the system. Does anyone from H2M have anything to add with that?
It's Karen Benson. I'll jump in. So yeah, so the PFAS treatment was actually started picking up more, like Steve had indicated, probably 2021, 2022. But as you'll see in the next couple slides, there are a lot of things that the water systems have to be watching, monitoring, and preparing for. So they kind of knew that this was coming because New Jersey was starting to announce it. They announced it in phases. Unfortunately for the timing, some of these things came out right in the midst of 2020 when many people were dealing with issues of COVID and reacting to that. But nonetheless, Waldwick was able to start planning for that and then have that done by 2024. And then the rest of the stuff, like the installation of the water main loops, was also something that was like 2019 in response to some issues with water clarity. And they were looking already into solutions for that. But then when PFAS rolled in, and that kind of took over as the priority to be able to meet the new regulations. So that was probably about the only two things that I wanted to add to that.
Thanks, Karen. Yeah,
Okay.
so kind of a good segue. I'm going to just pass it over to Karen to give a brief overview of some of the regulatory items over the years that's kind of helped contribute and drive the work that we've been doing.
Right. So essentially, water systems probably prior, like in the earlier 1970s, were much easier to run. There were fewer things that they needed to do. They needed to be able to pump the water, move the water, and do some basic chemistry to make sure that it met the then potable standards. This kind of shows just something that, and this was put together by the New Jersey DEP, so it has New Jersey state and federal requirements, and essentially things got more and more complex over time. So they started with a handful of compounds, and then they started looking for new compounds, and then they would sample those, and then the regulations would build off of that. As they saw different things, they also lead and copper is one that they started in the early 1990s, seeing the impacts of lead. So then that has been snowballing along the way, and it keeps getting revised to try to be more and more protective of public health. There's like, again, lists that they have to sample, sets of sampling. There's some that are like unregulated contaminant monitoring. Some things then they try to focus in on groundwater systems with a groundwater rule, the total coliform rule, trying to do that. Looking at how chlorine reacts, it's very good for preventing issues with health and killing off various bacteria, but then it reacts to other things and they need to monitor all of this stuff. So this is just kind of a snapshot of some of the things that systems such as Waldwick needs to always be keeping in mind and adjusting to and looking to the future and dealing to make sure that they're up to date. Next one, Belle, please. All right, and then focus.
Just before we make that transition, I'm so sorry. I cut you off, and I hope to do it in a way that contributes to what you were saying. So to repeat introduction, my name is Pat Cole. I'm a colleague of Karen's and Bill's here at H2M, and we in turn are servants to the borough on the subject of water supply. The slide that Karen had just paged away from made reference essentially to the entire Safe Drinking Water Act framework as it was deployed by the federal government and as it's regulated here in New Jersey. There's so much to digest in looking at these slides. The really sort of salient point to take away is that Waldwick, as a municipality of, let's say, medium size, and the owner of a public water system, is sort of a steward of its own system. And that's something that lots of people don't necessarily bother to think about, but it's important to internalize and to think about when you consider all of the recent and positive and constructive work that Steve sort of initiated this presentation with. It is always a work in progress that for many years, frankly, for many decades, as you look at this timeline, has not really been visible. But in recent years, number one, because as Karen had mentioned, the Safe Drinking Water Act has baked into it a requirement to review and to characterize unregulated contaminants on a rolling basis. But number two, because our technologies simply improve over time, the regulatory framework gets wider and more complex. So the upshot of it is Waldwick as a municipality owns a public water system, and its responsibilities for maintaining that system have gotten more complex over time. Tangent over, back to you, Karen.
Okay, we decided to just kind of take a look because every single one of these those boxes in the previous page have one of these arrow type timelines. So the top one is actually a bit on the PFAS, which I'm sure everybody probably got several quarterly letters advising them throughout time starting in early 2021 of what the levels were, what was being done, and seeing that progress to completion last year. And this just kind of shows again that in 2018 to 2020, the DEP was adopting it ahead of the United States EPA and requiring sampling. Then in 2024, as Waldwick was already putting their systems online, the EPA came out with lower standards, but Waldwick's treatment already addressed it to below those MCLs also. So as a lot of systems are now dealing with the newer regulations, Waldwick can at least look at that one and say, okay, we're done, moving on. So that just kind of gives that arrow of that timeline. And then the one below, that's an ongoing one that keeps getting new things with it, is the lead and copper rule, which includes now lead service line. New Jersey's ahead of the EPA again on this one and requires inventory and replacement. And as Steve indicated, there were letters going out. We can just give the forewarning, there'll be new letters going out in the next month or two. We're in another cycle and they're kind of closing everything to be like a August to September cycle instead of the November cycle. So we'll work ahead of that so that way maybe even have something set up so that way you guys can maybe ask questions before and understand that. Little off topic, but I'll mention it here. New Jersey's deadline for replacement of lead service lines, which is again one of Waldwick's priorities at the moment, is to finish that inventory and plan for those replacements, is 2031. Okay, next please. All right, this will be another one of a shared me to Pat and gets to the crux of why we are here. safe drinking water has two main categories. One is a primary drinking water standard, which are generally health impacts. Then it has a secondary drinking water standards, which are technically recommended, like upper limits in general, or sometimes lower limits. Those are more of the aesthetic things like tastes, odors, things that you can notice, but are not identified as health issues. So on the left-hand side, synthetic organic compounds, again, these PFAS, New Jersey's different MCLs. Again, you likely saw these in many, many letters. Box below, we apologize, it was a little small, but we did the best we could. Shows those EPA regulations, but again, New Jersey, the treatment that's in already addresses that, so therefore we're fine with that one. Moving on. Secondary standards, again, color, pH, odor, and taste. Things like iron, manganese, which you'll hear a little bit about, and just some of that chemistry that's naturally occurring in the water reacts with stuff in the system. And then that is one of the issues then that you likely saw with the water quality changes that you saw specifically over the past year, although we know from looking at the various comments that came in that for some people it's been longer, but at least now the platform is, so that way you can continue to advise Waldwick on that. Pat, you want to jump in with more of this, or are you good?
I'll just touch upon it briefly. Karen, I think, really thoroughly encapsulated kind of the big picture of drinking water quality. Primary contaminants are named that way for a reason. They are the object of concern for regulators and public health officials from the federal government on down through the states and straight to your municipal water system. Secondary contaminants are so named because they present aesthetic concerns, but the important part to remember about them is that often they're the contaminants that people notice the most. And that's fair. You sense them immediately. You can tell visually when water is discolored for whatever reason, often temporarily. And you also have sort of, as a human being, an incredible sense of taste and smell that alerts you, sometimes without trying, when water may seem off. But again, those are subjective experiences, and very, very often, so often that the EPA and the DEP regulate them this way, they're classified as secondary contaminants because their effects are aesthetic in nature rather than health-based. One final point to note, and we'll spend a significant portion of today's interaction talking about this, discoloration that you see in drinking water doesn't necessarily always arise from sources. Often when you maintain a distribution system, meaning the pipes that are in the ground that carry drinking water from your sources to your house, those pipes have a tendency, as with almost every metal mechanical system over time, to rust. So they can impart their own degree of discoloration to water. Part of their maintenance, both assessing it and figuring out how to maintain those systems most efficiently, will be the subject of what we talk about later in the presentation. So Karen, back over to you.
All right, I think I tag team with Steve on this one. Do you want to lead or do you want me to?
Yeah, I think maybe just before we really dive into what I think, is the reason most people are on, why don't we take a quick pause, and we'll kind of open it up for questions at this point. I would just ask that if anyone has questions, please, if you have more of just a general statement, hold that till the end for the main Q&A. Right now, we'll just pause for any questions for the content that's been covered to this point. So if anyone, you can just raise your virtual hand. Okay, I'm not seeing any, but I see that the mayor is on now, so I'm gonna just allow his mic. And Mayor, if you're on and you can unmute. Mayor, if you're there and can unmute. Right. I think we'll try again in 1 minute. And let me just see something here. All right, so I just want to go back and make sure that everybody. So again, let's try, if you have any questions to this point, please try and raise your virtual hand and we'll address you and unmute you. If not, we're just going to continue on. All right, I see one hand raised. 1 second. All right, I don't see that hand raised anymore. You seen anything on your end, Bill? All right. So we're going to jump forward. We'll keep going with the water discoloration issues. So obviously this has been a main concern that we've been dealing with right now for the past several months. It seems after the PFAS remediation work kind of concluded around last summer, that time around August to December, we received a lot of complaints. All of a sudden, discoloration issues, smell of, a metallic smell, metallic taste in the water. So, we started consulting with our H2M team here and our team from Boswell, who actually oversaw the PFAS remediation project as well. So we did, ask for their help, their recommendations and advice on what to do, which is why we started, we started with some hydrant flushing, which we'll get into a little more detail later on. Just to try and clear it up. Early on, we weren't aware of how widespread the issue started to become and how many people were experiencing it until we started to get a lot of phone calls. So I will say at that point is when we at the borough, we started creating a map to track all these complaints in a spreadsheet. And then, we formally started to enlist the help of H2M. We formed the Water Quality Committee through Mayor Giordano's assistance. And we kind of got a whole team really to focus on this issue specifically. So with that being said, we started having some meetings internally, kind of came up with a game plan. We were sharing all the data that we were collecting just through phone calls and talking to people with everybody just to get on the same page. And then we started to discuss about the hydraulic model, which we'll get into. So I don't know if Karen, you want to add anything to that?
Yeah, I mean, I'll jump in and we're going to go to a timeline next, so that may clarify. And some of this was also posted on the website also, starting again about last summer. I know a lot of the comments was actually there was the major water main break that was in June, and then as that got fixed, then it was the PFAS system going online. So it seemed like more complaints were started and expressed around that time period. So that's led to Mike and the water personnel doing some flushing, trying to clear it, trying to understand it as they were getting the new treated PFAS water in, and trying to see if it was like a short-term thing, just pockets of things. Seemed like it was effective, and then then it ramped up again. But as Steve indicated, that they started collecting the data, they started collecting it more formally, but we've been looking at that data, looking at the comments in it, understand that some is like recurring comments, but nonetheless, we are tracking it, trying to take a look at it, understanding where it falls in with different parts of the system. The timeline, again, June 10th was the major water main break that was repaired within a couple days. And then in July, they started putting together or actually started operating the new PFAS system, leading to then system hydrant flushing as they started getting complaints that went into August. Then in September, it seemed like the comments were going down a bit. So then they continued to go back to kind of operating their system. Again, when you do a big project like PFAS treatment, then all of your efforts, or the majority of your efforts go into getting that up and running. So November, December, I believe, then they started seeing an uptick again in comments and problems with the water quality. So by January, then they were talking more formally with us to do things more than just advise on some minor flushing and give some information, and to try to work on developing a much more comprehensive plan to identify and try to resolve this. Again, as Steve indicated, we have a couple different mapping ways of tracking this. This is one of ours, looking at number of complaints. And some of it you can see was water main breaks. We definitely saw upticks in complaints. Hydrant flushing, Waldwick is very good about notifying people, hey, we're going to be flushing in your area. You may see some discoloration, but still sometimes a complaint will come in, so maybe something didn't get totally flushed, or that the information didn't get through whatever reason. We definitely see like a couple more around water flushing events and certainly water main breaks. All of this is being tracked. The comment form is still available and will remain available, because as we work through this, the goal would be to obviously diminish the complaints, and then if you're having a problem, letting Waldwick know helps them then take a look and say, oh, this is something new, let's go investigate it. And I'll leave Pat with the beautiful looking pipe.
You know, I appreciate that, Karen. It is a subject that as an engineer and as a drinking water professional, it's spent a lot of my career focusing on water quality. It's a subject that I've had to visit and revisit many times over. And the picture that you're seeing there is not from Waldwick, but it is fairly representative of the interior of drinking water mains in almost all of the developed world. And that may seem like sort of a broad brush statement, but at the turn of the 20th century, when so many municipalities and utilities that serve the public were beginning to construct public drinking water distribution systems, they were using iron pipe. Often it was cast iron pipe, and often it was unlined. And while the focus of producing safe drinking water has to do with eliminating the possibility of bacteriological exposure, very often through chronic exposure to the drinking water that's conveyed to our faucets over years and frankly decades of service, we begin to see corrosion develop on the interior of our pipes. And for systems such as Waldwick's, those pipes can be composed of miles upon miles of pipe loop. Very often, these rusty walls that drinking water professionals describe as tuberculation, the result of corrosion circuits setting up and being allowed to exist over years or decades of service, they can impart a small but chronic color to otherwise clear water. It's possible that discoloration in water also can arise from traces of metals, often as you see up in this slide, iron and manganese, that are present in almost every groundwater source, frankly, in the Northeast. New Jersey itself is a particularly mineral-rich state when it comes to the content of our groundwater, both in North Jersey and in the coastal plain. And the solubility of those metals often comes down to the pH at which the system is maintained. Now, pH, not to go too far down that rabbit hole, is a bit of a master variable when it comes to maintaining and stabilizing aquatic chemistry for potable water. So the important part to understand as we dig through these issues is that it's always a balancing act, and always as stewards of the system, both the municipal officials that have authority over your system and us as vendors and contributors to sort of how you optimize the system, there's a balancing act in what we're doing to try to make sure that you're always getting potable water first, your primary contaminants are treated and eliminated, and secondary contaminants come after that. So again, as we go down, sort of exploring potential causes and solutions, we'll be looking to maintain that sort of sense of priority. So I think we're okay to move on to the next slide, and that'll speak to some of what we've done on behalf of Waldwick to evaluate existing conditions, and get a good understanding both of the layout of the existing distribution system and where we can best concentrate our efforts in terms of cleaning up the problems that Waldwick is experiencing. So you had seen prior, a few slides back, that your water distribution system in many ways mimics essentially the layout of the town. That's intuitive when you begin to think about it. All the residential and commercial parcels that is, in town that are served need to be connected to the water system in some way that makes physical connection easy. That being said, the material composition and vintage or age of the pipes varies greatly. And one of the sort of forensic analysis approaches that we as engineers can use in figuring out where your distribution system is most likely to be corroded or tuberculated, as that prior slide had described, is to go in and begin modeling the behavior and the configuration of the system. When I say modeling, I mean using an electronic software system to not only model its layout and its size, but to use field data to understand the degree to which the pipes in your system are constricted. That itself gives us inferential data about tuberculation, corrosion that has occurred really across the system, and we're able to represent that in our model through the derivation of a set of roughness coefficients. So in layman's terms, what we're doing is modeling your system electronically and stress testing it to get a sense of how water flows through it and the degree to which it is or is not constricted. That in turn lets us have a good inferential sense about where we're most likely to find discoloration in the system. And we use that in conjunction with the log of water quality complaints that we've had to figure out where to focus our efforts. So I think we're ready for the next slide. Okay, for everyone that lives in town, this view should be pretty darn familiar. You may have seen it in your favorite online mapping system or on your phone while you're trying to navigate from point A to point B. Again, your drinking water distribution system pretty thoroughly approximates the layout of the borough. Now, as sort of an explainer for what you're looking at, you're seeing the layout of water main throughout the town, and the legend that you see in the upper left of the screen gives an idea of pipe roughness. The thing to understand about that is that as the pipe roughness increases in value, the water main itself is less constricted. So as system owners, as residents, and as folks that work on analyses like this every day, we are looking for systems that are less constricted because they promote flow. They lower the energy that you're required to convey water from your sources out to the taps, everyone's kitchens and bathrooms and what have you. But more importantly to the analysis that we're doing today, the pipes that are lesser constricted, the ones that you see characterized as green or blue, are going to have a lesser chance of imparting discoloration to your water. The pipes that are more constricted, the ones that you see keyed as yellow or red, are far more likely to be tuberculated, meaning corroded, and therefore constricted, and in their constriction have a greater possibility or probability of imparting discoloration to your drinking water. So that was a lot to digest, but this is sort of a key in understanding what we're able to do in terms of forensic analysis on your behalf that doesn't involve essentially excavating and test pitting the entire town. This is a productive and minimally invasive approach that is accepted as one of the industry standards for evaluating problems of water discoloration in potable water distribution systems. So again, to acknowledge, lots to digest. I'll pause here, and we as a group are receptive to answering your questions. Steve, I'll defer to you to moderate.
Yeah, I see some hands going up now. I think we might have had an issue the first round, but we seem to be working
Okay.
now. So I'm gonna start. Just you should see a pop-up once your mic is enabled.
Hey, can you hear me okay?
Yes, we have it.
Okay, Mike Ritchie here. Thanks for the presentation thus far. Some of the red areas that you have here are fairly new developments in town, presumably less than 10 years. So it would be hard to imagine that those pipes have kind of undergone, many years. So really, how good is constriction at modeling the problem at hand here?
If my colleagues are comfortable, I can tackle that. So Mike, I would say, first of all, awesome question, sort of smart, intuitive question, and jumps right on to one of the issues that often confounds engineers when they attempt to model systems like this, because you're right, age really closely correlates often as a first guess to where we expect to see constriction. But one of the other elements that sort of strongly contributes to that possibility to corrosion that arises from that tuberculation function comes down to both water chemistry and materials of construction. And in this particular case, as we see observed over and over again through the interaction of both your finished water and the pipes that are in service in those red areas, we're simply observing and trying to report back to the town truthfully what we've observed in terms of constriction. That sounds like sort of a too neat explanation. It's too easy. It's just water chemistry, right? One might say, in hearing that explanation, that's a little too easy. In situations like this, where the age of the pipe is counterintuitive to our findings from forensic testing, from flow testing and modeling, what we'll often do is make a recommendation to go back with the town's public works crew, or specifically their water distribution crew, and test pit selected areas to attempt to verify what we are modeling. So again, your question is a very valid one.
So in that instance, do you test like chemical composition of the water, various spots in town, pre and post perturbation, to try and map back where the actual issue is potentially the root cause? Okay.
I cut you off and I apologize for that. So that not only is that exactly right, so getting an understanding of aquatic chemistry at each of those sites, but also taking physical coupons, and that means cutting out a small section of pipe to be able to examine it visually, take tests about its composition, and make sure that we get actual visual validation and compositional validation about what we think we're testing.
Pat, the other thing I would just add quickly too is where we're seeing customer complaints. So there might be parts of the system that the models say could be an issue, but we're not seeing that in complaints. And also it's a newer system, but maybe its design constricts some flow somehow. So that's what we're seeing in the model, as opposed to anything affecting customers. But again, that's all part of the analysis that's ongoing at this point.
All right, Mike, if you're good, we'll move on unless you have a follow-up.
Good.
All right, thank you.
All good, thank you.
All right, we'll move on to Bianca. You should be able to unmute.
Yes, hi, thank you. I have two questions, but I think my first one is just a continuation of what Mike had brought up. My question on this was more of, what's the time frame for the discovery of the issue? And then what would be the potential resolutions? Do we then change the pipes within those areas? Is there aggressive cleanup? Can you give us some ideas of what that would involve?
I certainly can, and I'll ask my colleagues to feel comfortable jumping in and cutting me off as I explain. I'll try to sort of give Ms. Morosi, if you're comfortable, the Reader's Digest version of it, because we do plan to go into some more depth on that subject later in the presentation.
Sure, not a problem.
No, but very valid question, sort of on point. We anticipate conducting additional testing over the course of the next several months. So going from the summer into the fall, sort of backing up and supporting some of the data that we're seeing now from our initial testing. And then downstream of that, the solution set that comes from a situation like this, or best supports a situation like this, is to begin with the simplest and least costs and move into areas of greater complexity and higher cost. So we would start by working with your own public officials and leadership to come up with a system of flushing that itself begins with what they're doing now, but enhances it using our model and steps through a series of standard protocols that the industry uses to better and more rigorously flush your pipes. From there, we'd move into mechanical cleaning, potentially relining, and in the absolute extreme, because it's the most costly option, we'd consider recommending that you replace pipes. So we'll dig into that in some more depth, but again, that question cuts right to the heart of what we're talking about today.
Thank you very much. And my next question kind of goes back a few slides, but it's regarding the aesthetic water quality that you had brought up. You know, from my recollection, the issues that we've seen from an aesthetic, standpoint has been a little bit more than a year, possibly 2 years. So when you talk about that, what aesthetic quality issues would then be acceptable to ignore?
Okay.
And I don't mean to be difficult about that, but I think, I know that some residents have seen some slight discoloration to some heavy discoloration, right? So I think getting an idea of what should really be a red flag would be quite helpful.
I do agree. And for context, again, really enjoying these questions. To me, they're informed and proportional to what we're talking about. I'm the water engineer in my own town. My wife is a teacher in the town that we live in, and we have 3 teenage kids. So my wife and I are exposed every day to complaints about just about anything you can imagine, drinking water quality included. And I understand where it's coming from and how it can affect people's lives. So to sort of characterize where we would want to be, because we began the presentation by talking about the notion that secondary contaminants, in some sense, are subordinate to the import from a public health standpoint of the primary contaminants. Again, secondary contaminants are themselves aesthetic in nature. New Jersey DEP, right, our regulatory agency with primacy, they make reference to secondary standards in their own recommendations and best practices and suggest to public water systems, such as Waldwick's, that they maintain concentrations no greater than twice the secondary maximum contaminant levels. So from a concentration and testing standpoint, those would be sort of the ceilings that we would shoot for as your advisors, mostly because it falls in line with the recommendations of our own state regulators. But we do hope to do better than that. The important part to understand or to contextualize that response is that if we're generally right about the causes, in other words, if this is not mostly a source problem, but is rather mostly a problem that arises from the condition of the interior of your distribution system, then the solution to it is something that is probably going to occur over months or years, mostly because it is not overwhelmingly a health concern, but there is a way to solve it. We are attempting to make sure that we don't recommend solutions that result in something that industry professionals call rate shock. In other words, as a sort of sledgehammer solution, we would recommend that a town of your size and complexity replace almost the entire distribution system and hopefully solve the problem. But I mean that as a sort of extreme example to cite that we wouldn't want you to do that. We think that would be inefficient and a waste of money. So we're trying to sort of right size it in such a way that we get to those secondary maximum contaminant levels in a way that spends the least, frankly, of your money.
So I do understand that, but as an individual resident, I guess, the question is more of, what aesthetic qualities, I guess I don't personally have issues because I put filtration systems in my household, but I know other people are not able to do that, and they can't be calling the borough every single day that they have, yellow water. I mean, or they could, but then I guess the question is really, at what point do they ignore that aesthetic quality, or do we have to just wait for there to be more study to see what that would be?
So the best way to respond to that, again, because if I may, Steve, I'm going to a little bit put words in your mouth and I'll ask you to modify them. The objective of this work is to improve the water quality in a way that is most acceptable to the most number of residents, primarily because the water quality concerns that we have here are not regulated in a primary fashion. That sounds like an incredibly subjective answer and sort of unsatisfactory. The primary objective on our end is to get those secondary maximum contaminant levels, so the iron and manganese that you would see presented as discoloration at your tap, below the state's secondary maximum contaminant levels, below the concentrations that they recommend. Now, when we make a recommendation about how to proceed, both how quickly to proceed and how much money to spend, our set of recommendations, in other words, the range of options, are going to sort of characterize to both your leadership and to you as citizens, here is a range of options that you can pursue. Here's how quickly you can pursue them, and here's how much money you are likely to spend in that process. We can make a recommendation to you about what we have seen most effective in other towns, again, of your size and complexity, in getting people to the point where their discoloration only seems occasional rather than chronic. But then it will be up to you, both your leadership and you as a served population, to figure out what that right size, what that ideal spot is. Some folks are more comfortable because it's a greater priority to them spending more money. And again, our objective is to be your support system and recommend what we see satisfying other systems of similar size and complexity, but we would be deferential to you because we'd never presume to spend other people's money.
Got it. Thank you very much.
Steve, do you want to jump in a little bit, or did Pat put good words in your mouth?
Yeah, I think Pat put pretty good words in, but yeah, I mean, just simply for us, I believe, and I'm certainly not going to speak for all the council, mayor and council as well, but it's really about balance, right? So we don't want to just go in there aggressively and replace all this water main, spend millions of dollars, without knowing that it's going to really be effective, both cost wise and, just to fix the issue. So that's what we're doing. That's why we're doing such a deep dive on the system, having this model done, having H2M really analyze every aspect for us. So we know we're being strategic about it and really going in the right direction, making the right decisions, and being, cost wise as well.
And I will jump in and just say that, yes, we did see in the comments that when people started at using the portal to lodge issues, that there were a number of people who said that this is not a new issue. So where we started hearing about it last summer, it was not the first time that at least a number of people were experiencing that. We're looking at trying to wrap this up probably over the next couple months to at least be able to give some good first recommendations to Waldwick and start making those plans to fix that. Steve had mentioned we'll have another one of these in the fall. Certainly, if you're having a new problem or an increased problem, I would say please continue to log into the portal and let us know. We're going to continue to track it. And then as we get into the fall, we start putting in corrections, then we'll probably ask for people again to, if you're still having problems, let us know so we can see if parts of the system have been addressed, and we have, then we can focus on any people who haven't. And that way we can kind of start fine tuning it to the point where ideally nobody has problems. Would be the ultimate goal, but obviously, that's always going to depend, but that would be the perfect world, is that everybody would be happy as far as the clarity of their water in their house.
Thank you, Karen. All right, we have a few more questions, so we'll go with Catherine. All right, Catherine, you should be able to unmute.
Hi, sorry. So based on a municipality of our size, would best practice or typical practice even be that the town should be or would be reaching out to the residents to survey their water quality rather than sort of the burden of proof and reporting being on the residents to be calling or logging into a portal. I guess I had just hoped that if we were going to spend this money and do such a deep dive, that we could have a more objective sort of data set than based on sort of who's savvy enough to call and report or log into a portal. I think my other question is based on our filtration systems. A lot of our town has filtration systems. How much of these secondary concerns that are above, standards are being caught and then subsequently not reported at all, based on the, thousands of dollars that people have independently put in their homes so that they feel, based in fact or not, that, the water they're drinking is safe. And how's that affecting the data?
Sure. So I'm going to actively ask Karen to modify me as I first respond, and I'll try to hit your questions to my memory point by point, Catherine. The first aspect that you had asked about is the borough's responsibility to come in and do testing of this kind, and I can tell you that the state.
My question was actually to survey water quality. So rather than having people report independently about discoloration, odor, what have you, would be to sort of solicit feedback from people.
Got it. Thank you for correcting that. So to contextualize that a little bit, the borough, as the administrator of a public water system, has a very complex array of water quality that it's compelled to sample for, analyze using a certified drinking water laboratory, and report on both on a monthly basis and through sort of a framework of water quality reporting that can occur quarterly, annually. There's a sort of a range on that. When it comes to secondaries, the state does not compel outreach of that kind. And as a result of that, there's no published or regulated industry standard for an approach to solving those problems. I can tell you that the approach that the borough has used, soliciting comments from people that are affected, was in part used, and again, Steve, deferential if you had other motives that you know of or that we weren't privy to, but to make sure that the effort was pinpointed and that the analysis was pinpointed to the folks that were the most affected. I'll move downstream to the point that you raised.
They were most affected. I just want to clarify that they reported they were most affected, but perhaps all that wasn't collected.
So you're right about that in the sense that because there's no true objective framework for this, in other words, there's no grid, there's no distribution, there's no frequency that's imposed either by the federal government or by the state government. It's difficult to objectively say, hey, we've solved all the water quality problems, but I'll put an asterisk on that in responding to the subjective body of data that we've gotten. And again, we can, I think as a group, all sort of agree to its subjectivity and take it with the proper grain of salt. The analytical methods that we've used to respond to it and try to characterize the distribution system as a whole have themselves been more standard, more industry standard, and intentionally more objective in both their approach and the results that sort of we acquire out of that to inform the set of recommendations that we make. So I'm sorry, I cut you off. Go ahead.
No, that's helpful.
Yep.
Let me jump in a little. Oops, sorry, I'm stepping on you, Pat. Finish.
Go ahead. Nope.
So essentially, as was indicated at the beginning, as January came and they saw a continuation of the complaints, and you're correct that people weren't reporting it and some people probably still aren't reporting it. But basically, Steve and the Borough of Waldwick were working to be as transparent as possible, post things on the web page and allow for that portal so anybody could basically put in and provide some information. But your point is well taken that not everybody is familiar with that. So certainly we're going to take that under advisement and then look into another way of doing that. In general, sending out mailers usually not as effective as people would hope. And certainly, again, going back to the lead service line inventory, there's been a lot of requests for information and many people don't respond, but that doesn't mean that we can't try to enhance that. So Steve, we can talk about that later and then try to develop something that maybe reaches people that it's not just through this portal and is more in their, allow them to feel like they're being asked almost one-on-one through either some add to the bill record or something like that. We can discuss some options. So thank you. That was a good point.
Thank you for recognizing what I was trying to say and addressing it.
Yeah, I'll jump in too and say, we did do kind of early on when we first started getting some complaints in specific areas. We did do, some additional testing and found elevated levels of iron. So we were pretty confident that that was really the main issue that was happening. And again, yeah, the form, we put out, we wanted that additional feedback. We were really trying to engage with everybody and make sure we're capturing as much as possible. Going forward, the plans are through the summer and the fall, we're going to take some sections of pipe out. We're going to do those test pits and kind of dig in a little bit more on that and be a little more active with testing in specific areas.
Well, one quick point I would like to add on to what you said, Steven, is that part of the reason we wanted the form the way that it was structured was because we were hoping to receive feedback from residents that's tied to a timeline in which something was observed, so that in the event the system was being operated in a particular way, as in one well was online while others were not, we would be able to start to determine what the source could be as we were starting to dive into the details with the system. So, but your comment and feedback was certainly very solid, and we appreciate it.
Yeah, thanks for that, Bill. All right, we are gonna take a couple more questions and then I'd like to get back into it. So I know we have several hands up, but if people can wait, I think we might answer some of these questions because we are going to cover a lot more in the upcoming slides. So why don't we'll take two more. Right now we'll go with the Stanton family. You should be able to unmute right now.
Hi there. Thank you very much and really appreciate all of the questions. I'm a little stuck on this slide because I don't really know what it means and perhaps I've missed it because there's a lot going on in the background. But could you please explain less than 55, the streets that are in red versus the streets that are greater than 100 in blue, and what that means in layman's terms to the residents that are on this call, please?
Happy to. Yes, good question. Simplest terms, the pipes that are red and yellow are rougher and more constricted based on our modeling. The pipes that are, and that's inside. The pipes that are green and blue are smoother and less constricted and allow more flow.
So does that mean, and just a follow-up question, and then I will let you get back in to take the last question. Does that mean the red and yellows will be prioritized?
At this point, the correct answer is yes. But to sort of build on what my colleagues had mentioned, we're still building a data set on behalf of you as customers. So the sort of properly humble response would be that it depends on the results of our further research. But as we see it right now, those red and yellow areas are focal points for us.
Thank you and understand.
All right, we'll take one more question from Andrew. You should be able to unmute now.
Yes, can you hear me?
Yep.
Okay, my question is, are there any areas in town, and I know you tangentially walked through the process of identifying the restrictions, thoroughly washing them out, et cetera, have any areas of town had that process duplicated? And at what point do we stop trying the same efforts and just replace? And are there any areas in town that have been identified that just need to be replaced?
So I can begin to tackle that question, but it's a very timely and pertinent question on in sort of the come up to our next few slides, because we plan to talk about sort of what the next steps are. There are some areas in town that based on the data that we currently have might be good candidates for replacement, but there are some interim steps that we could recommend taking that might cost you a little less money as ratepayers, but might get you to the results that we had talked about in the original question about, hey, what does it take to actually achieve these water quality goals? How do I get clear water at my tap? So we have some steps to walk you through. If you are satisfied to sort of wait to hear about them in greater detail in the next few slides, or if you'd like to, we can exchange. Okay.
No, I'm satisfied. I just one real quick follow-up. If you did replace,
Yes.
is there any concern, if any, with a more modern system coexisting with the older infrastructure?
For sure. There are concerns to begin with mechanically, because we have to make sure that the system has physical integrity and buttons together, and dissimilar materials are always one touch more challenging to join up. But modern pipe materials are, let's say, protected intentionally by design against physical degradation, some better than others. And given the water quality results that we're beginning to understand about your system, we'll be able to make better recommendations to you about materials of construction in selected areas of the distribution system that themselves have become chronic problems.
Thank you. Well done. Great job so far.
And I'm not going to belabor it, but just to jump in, because I know Mike could not be here today. All of this did start with him doing various flushing and trying different things to try to clear it. And again, it was showing promise, and then it came back. So essentially, this whole effort with hydraulic modeling and taking a look at chemistry and trying to log the areas where people were commenting more on issues was to not go running and do too much too soon before we understood what those potential impacts, and that's kind of where we're at now, is we have this, we're doing some final understanding and data collection so we can then provide those next steps that Pat's going to discuss more than we will in the next couple slides.
Yeah, thanks for that segue, Karen. I think we'll move on and just restate, we are going to have additional question time. So please hold any, there's more coming up.
Yeah, yes, indeed. Steve, thank you for that. So looking through sort of, let's say, the tool set that we and that your utility leadership have available to them for potentially improving water quality in your distribution system, I would say that there are several. You see them listed here. The very first bullet point, conventional flushing, is something that the system has been using on a biannual basis, and that's reflective of the industry standards. There are a number of different reasons. I know that everyone's time is precious, so I won't bore you with the details of that, but that is the typical approach. And I think that we might agree as a group that so far that has not necessarily solved the problem. So understanding that, the next step that we take, and one of the reasons why we were so keen to model the system, is that the objective of flushing is to achieve a scouring velocity in a given run of pipe. And sometimes the way that distribution systems are built with their size, they're meant to be able to assist when distribution systems are supplying against an emergency like water main break or a fire. They can be slightly oversized. So to promote the flushing that's necessary to really scour some of the sediment and oxidized metals that present discoloration that you see both in tuberculation and in sediment that collects in low spots in the distribution system, we can model a program of what's known as unidirectional flushing, which essentially boils down to having a program of valve shutoffs and turn-ons that allow your distribution system operators to promote a very high velocity inside the pipes, and therefore to clean them more thoroughly. Not only does it scour sediment out of the system, but it can in some cases break down tubercules that have developed on the interior walls of pipes and give you as customers lesser opportunity to be exposed to discoloration.
Pat,
Okay,
we're going to add the visuals to this as you're stepping through.
sure.
We have the visual thing, so that way people can have the picture and just keep up with that. So as you're talking through it.
Right, and I have a fair sort of memory of the order of operations here. So folks that live in town, you should have once or twice in your lives seen a distribution crew that is flushing a hydrant. Again, that's standard operating procedure and occurs typically in the spring and the fall. And the objective is to simply promote the clean distribution of drinking water throughout the system. We may, as a result of our modeling, recommend an increase in flushing your distribution system, both at points where discoloration has been reported, at dead ends, and at points where, through our modeling, we either recognize low points in topography or places where chronic slow flows occur. So, in essence, our objective will be to begin with to make your conventional flushing system optimized, and then potentially to use our hydraulic model to give you a program of unidirectional flushing that really focuses on places that we believe discoloration is sourced, if you will, in your transmission and distribution systems. So again, the big difference there, you're looking at these pictures that are sometimes hard to decipher for the casual observer. There are closed valves in that diagram that really promote higher velocities in our flushing. So moving on to the next slide, once you have sort of exhausted flushing as an option, and if we have not sort of achieved our water quality goals, the next approach is analogous at the system-wide scale to what many folks are familiar with as an angioplasty, and the use of so-called PIGs, which are essentially mechanical scraping devices to remove corrosive deposits from the interior pipe walls, is a very well documented industry approach. Again, the big differentiator between this and either conventional flushing or unidirectional flushing, of course, is the use of the mechanical scraper, number one, and number two, the fact that this work is typically performed by dedicated professionals. So there's a cost difference in that you have to pay for their time and for their materials. And our recommendation in using this approach, if we recommend it at all, will be that we deploy it in locations where the greatest potential for improvement is either suspected or observed from the process of what we had described earlier as pipe couponing, meaning taking samples and verifying the inferences that we make from testing that there is tuberculation or chronic corrosion in the interior of sections of pipe walls where we would recommend deploying these systems. There's another option, another format option for pigging, for mechanically scraping. And this option, ice pigging, uses a slurry of ice to mimic the function of the mechanical scraper, but it's often used for distribution systems that either have more delicate pipe walls, are extremely aged, or have a series of very tight bends that will not allow the safe passage of those mechanical scrapers or pigs. So a sort of plan B, if through the process of testing and couponing, we have some places in the distribution system that we want to clean and keep in service, but that we are concerned about mechanically breaking down. So we can move on to the last option, and again, this is the last of the flushing options, flushing and scraping, or internal removal options, because it's the most costly. This uses a portable unidirectional flushing system with filters mounted on a truck body, and it's trademarked as the so-called no-des system. So there are professional vendors out there in the marketplace that serve distribution systems like the one that Waldwick owns. And this system can be deployed to pointed, selected locations in town and really develop the highest velocities that the pipes can mechanically tolerate to use hydraulic forces to scour out the interior of your pipe walls. And again, this is of the options that we described on a unit basis, the most expensive, but has the potential to be the most physically effective. So we had sort of initiated this conversation by scaling the options from the simplest and least costly to more complex and more costly. And this is where we end up as sort of the option of last resort when it comes to scouring your existing pipes. So the next option, and I think that everyone on this call probably could have made the inference that we would at least talk about this, is the notion of replacing some of your water mains. If some of them have low physical integrity, have exhibited frequent main breaks in the past, and if we can make either an inference about their internal quality or coupon them and verify that visually, it might make the most sense for you to replace certain lengths of water main. The reason why we approach that option so hesitantly is because, as we know, it's a challenge to make capital investments in anything that a town owns, because every municipality is conscious of how they spend money. And that's for good reason. We all maintain a household budget. The municipality does it on the townwide scale and the borough-wide scale. And this option, while potentially highly effective, very likely the most effective, is the one that would cost the most in terms of a capital investment. So I'll just pause there and return back to my colleagues. Bill and Karen, have I missed anything that you would consider pertinent in that description?
No, I would just go and kind of reaffirm that essentially the steps up until now were to get us to the point of figuring out which of these would be the most beneficial for the borough of Waldwick and most effective for different areas. And again, it's probably going to be not one size fits all solution. It's going to depend on those parts of the system. The other thing I would also mention is that toward the very beginning, when Steve went through and he talked about like the various projects that they're doing, the one was called asset management. And water main replacement program is definitely something that is on that. It's actually required for mains after a certain age. Waldwick goes through every single year. They need to assess all the lines, the ages of the lines, and how many breaks that they're seeing, different things like that. So that way they can continue with this planning for it. Things like PFAS treatment and lead service line replacements, of course, impact that, in that they could have the best ideas of we're going to tackle this problem, and then a new regulation comes out from the New Jersey DEP or EPA, and that being a health-related issue takes priority and then steps through. Right now, if you're wondering for the fall, the other thing too is that the peak demand periods, as we refer to it through a system, is through the summer, where people are using maybe more water. So part of this timing will work out really well also, where we will wind up finalizing our thoughts, talking with Waldwick and helping them plan, but it'll also be a time where you don't want to do a lot of this while people are maximizing their water, because then it adds a lot of more flow through the system.
Very well said. Appreciate that context, Karen. Go ahead, Steve.
Yeah, I was just going to say thanks for that, Karen. That was helpful. And again, just to touch on this slide, all those options, obviously, we're evaluating the best route to go and trying to be strategic about it. We can't hide the fact that we need money to do all these things, right? So our rates help pay for all these improvements. Those are all the rates that everyone pays for the water. And even, if we go in and borrow large sums of money, again, that gets reflected back in the rates and the ratepayer. So we do really want to be strategic, targeted in our approach with this, and just be smart about it. I mean, really, it's all about balance once again. And we're exploring all different options for funding mechanisms. Like I said, it's through the rates. We could borrow money. For the PFAS project, we did utilize the iBank, and that was a great, option for us. Very, low interest loans through that, and we actually realized a $2 million forgiveness as part of that loan. So, that was about a $6 million project. We did receive about $2 million in forgiveness, which is helpful. That's not always going to be there. So while the iBank and H2O loan portal may be there as a financing option, we're not always going to look at that money back. So that was a benefit to us. But, as Karen mentioned, we're trying to aggressively make improvements, but then we keep getting hit with these different regulations, and we have to take a step back, focus on that, and those could take years before we hit those requirements. So it's a constant battle, and again, it's all about balance. So thank you.
Very good. Yeah, that's really the most succinct way to characterize this, Steve. And that's what we would strive for, and probably the greatest single recommendation that we would make as your advisors and consultants in looking at these remediation options. I think it's important for everyone who's viewing and sort of taking notes along the way to understand that the conventional and unidirectional flushing don't really cost much beyond your existing operating budget. If you were being rigorous about their costs, you might account for them in the single-digit thousands of dollars because they take the time of distribution crews to go out and attend to. But again, that's to a certain extent baked into your tax base and your rate base already. The pigging operations where scraping is performed, you might spend in the range of tens of thousands of dollars. And then when you move up to water main replacement, and this is intuitive because all of you, I'm sure, have seen your municipal budget in one way or another, capital projects can cost hundreds of thousands of dollars, and often involve not just the use of existing capital, but as Steve had alluded to, potentially bonding for long-term expenses and the use of, as Steve again had alluded to, the iBank or the New Jersey Infrastructure Bank, which is a self-liquidating funding mechanism, low-interest loans, and occasionally grants for essentially the upkeep and stewardship of public environmental infrastructure. So there are ways to soften the blow on big investments of that nature. But at the end of the day, our job will be to try to accumulate enough data to make a good faith recommendation to you about how to spend money on this scale the most efficiently. So if we could please move to the next slide. Okay, so we began this presentation by talking a lot about both your sources and the distribution system that you manage. The borough itself is over 100 years old, and there are parts of the system that have aged and exhibited corrosion. There are parts of the system that are very young and have also corroded or exhibited the signs of corrosion, internal corrosion, faster than we might have anticipated. The important thing to remember in contextualizing all this is that those pipes are actually carrying water that we intentionally treat both to disinfect, to remove contaminants, but also to perform a process, if we think that this will help, known as passivation, meaning to make the water itself less aggressive, potentially, to the interior of pipe walls. And so once we begin to sort through the data that we're able to get from physical system testing and modeling, a secondary aspect, but potentially just as significant, will be us evaluating the stability and the passivity of your treated water quality out in the distribution system and attempting to identify ways that you can make your treated water more passive, less aggressive, and less prone to promoting the corrosion that you're now dealing with, having occurred on a chronic basis over years or decades of service. There is a bit of a technical rabbit hole to go down here. I'm not sure that many folks signed up for a chemistry talk this evening, but one of the primary ways to achieve a more passive water, first, is to look at reaction kinetics in the way that the water behaves in relation to your pipe. Often that is improved or optimized by optimizing the pH of your finished water, of the potable water that goes out into your distribution system and then is distributed at your kitchen sink or what have you. Those changes are very carefully recommended. One of the more simpler and straightforward approaches is to evaluate the possibility of feeding what's known as a chemical sequestrant. And once we have done, let's say, the harder physical work of optimizing the distribution system, either through flushing or pigging, scraping, as we described, it's possible to make the water more stable and less prone to discoloration by feeding a chemical sequestrant that itself is intentionally formulated to make it 100% safe to drink and is fed in very low concentrations. Part of the testing that we would perform on the borough's behalf is bench scale testing to optimize what that low dose would be. So again, we had discussed prior a timeline of the scale of weeks to months for beginning to sort of understand what our best options are for physically cleaning out the system. In parallel to that, we would be testing and evaluating water quality so that while the physical optimization was performed on the system, recommendations could be made downstream for optimizing water quality. There are next steps involved in work of this nature. Again, I think for us being sort of honest and straightforward and properly humble about this, the evaluation itself is a work in progress, and it is primarily a science, but is also a bit of an art. There's an intuition that goes into spending our time the most efficiently on your part to achieve the best objectives, again, in a time that makes it relevant for you as users. We're going to attempt to spend the next several months, as I had characterized, really trying to give borough leadership, in essence, the best bang for its buck, an understanding of what we know about your sources, your distribution system, and your water quality to give you the best chance over the course of the next several months to several years to optimize that system. When I say several months, I mean deploying those simpler and lesser costly solutions. And when I say several years, I mean planning for, potentially designing, and finding funding for the handful of places that might justify actual pipe replacement and investing more significant sums of money. The most important takeaway is that last line that you see on this slide, and it's reflective of the approach that Steve has emphasized over and over again. Each of these solutions really does build on the last one, and the objective in our evaluation about both effectiveness and cost is finding that balance so that every dollar that we recommend that you spend actually has a positive outcome and has that outcome in a timely fashion. So I think, Steve, if you're comfortable, I can hand it back over to you to moderate any final questions from the attendees group.
Sorry, should learn by now. I was muted. Yeah, I'll just note before we jump into the main Q&A session, just please reach out. You could always reach me by my email listed here. It's sneale@waldwicknj.gov. You could give us a call. I will tell you, email is probably just the best way to track. Continue to use that form at the URL that's shown on the slide, good or bad. So if you had an issue and it's no longer there, let us know. Just submit that form. You don't have to submit every single day. If you continue to have discoloration, I can tell you we haven't noted. If you continue to have that, we know it's there. So we're basically operating under the assumption that the issue is still there until you tell us it's not, if that's fair for you guys. So with that being said too, I do see the mayor on, so I'm just gonna unmute you, Mayor, and if you want to say a few words, and then we'll jump into the Q&A.
Did you hear me?
Yep, we got you. Oh, you're muted again, Mayor. If you want to unmute again, we did have you.
How that?
Yep.
Okay. I just want to apologize that you couldn't hear me before, but I'm at home on my computer and I usually don't use this computer at home. First of all, I want to thank Karen, Bill, and Pat for taking the time to explain to all of us and our residents what's going on with our water. And I would like to thank Steve, of course, the committee and the council, and most importantly, I'd like to thank the residents for being very patient with all this. I know it's not easy. I know a lot of people get frustrated and they get mad, but we are trying and we will continue to try, and we will continue to make sure that we improve the water quality in our town. Thank God the water is safe, but a lot of people feel it's not safe. But we're going to try our hardest and we will do our best to make sure that everybody is satisfied with what happens moving forward. And as Steve said, I know a lot of people don't want to keep on calling and complaining, but the only way we know is if you call us and let us know. And that's the only way we could know what's going on with the water situation. Our DBW and the rest of the staff will be more aggressive in everything. You can see that we're trying our hard, we're trying to do the best we could, and we will continue to do that. But we need your help also. It's easy for me to say it, but together we could solve this problem that Waldwick's having. Thank you, Steve.
Thank you, Mayor. All right, so at this time, we'll jump into the main Q&A. I have a list of hands, so we'll just get started if everyone's ready. We'll start with Angela. You should be able to unmute.
Hi there, it's Angela Smith. Just to take off on Cassie's question, instead of the modeling has mainly been done, at least from my understanding, on self-report, correct? On people self-reporting that they're having issues.
So
The tracking of the complaints, yes, not the hydraulic model is totally separate, but we're pairing the two.
You're pairing them up. I was just thinking, in order I know you're wrapping things up with the modeling, and it seems like you have a pretty robust model, but to possibly do some type of a text survey, text alert to residents. I know your response rate might be better than trying to do a mailer of some kind, but
okay.
Yeah, thanks, Angela. That's a great point. We could definitely put that together. We'll
okay,
read
that way
it
you
on.
might get a little bit more people to respond and not just the ones who are making all the noise, which obviously they're the ones you need to address first, but just to increase that robustness might help.
And as far as wrapping up, it's really more of a, we are building this tool to help with the first wave of it. But this becomes an ongoing tool for the use of the Borough of Waldwick. So if there are new situations or any changes to anything, then we can use this as a predictive tool as far as trying to figure out what's going to go on. And I'm speaking as the non-engineer of the group, but nonetheless, I figured that my colleagues will jump in and correct me as I am. But it's not like we get to the end of this and then that's it and we're done and we close the door. This is an ongoing thing, working with Waldwick and continuing to assist them with things. It may not be more on the hydraulic modeling anymore, but it'll be continued to be an assist as needed.
Appreciate all of your information. It's been really helpful. Thank you.
Thanks, Angela. All right, next up, Andrew.
Can you hear me?
Yep.
Okay, I heard before, and I gotta ask Steve. I know I heard a $7-8 million number. My question is, have we been allocating yearly budgets, money for capital improvements for this, and has the cost of trying to keep up outpaced that allocation on a year-to-year basis?
Yeah, great question. So yeah, every year we do allocate just a general water infrastructure improvements line in our capital budget. Typically it's been in the range of 100 to 125,000. Actually, this year the council did approve, we doubled that So we did allocate just 250,000 strictly towards kind of general improvements, repairs, materials. And that's in addition to other specific projects too, and other capital items. So our water capital budget this year was about 1.1 million. So with that being said, looking at our rates, we are in the midst of a rate study right now. So there's going to be more to come on that soon. So I won't get into too much detail because we will follow up on that. But we do know, just kind of looking at our rates and some of the surrounding areas and our costs, that our rates are low overall, I would say. So, you know, we obviously want to balance that. We don't want to just spike rates for no reason, which is why we're kind of doing a lot of legwork to collect as much data as possible. So that is kind of where we're at. But yeah, we're definitely looking at the rates. We're going to analyze those and see what's necessary. And that's not going to be, you know, in 1 year. You know, that's a long-term thing, probably a phased-in approach, you know, maybe 5 years, 10 years down the road, just to make sure we are caught up and you know, we're making back what we're putting into it.
Thank you.
Right. Catherine?
Hi. So this may be a dumb question, but if we know the water is safe, which you've, you know, told us how you test it and that our water is safe, and I echo the mayor, thank God we have safe water. If we know that there's a chemical additive that can just make it less corrosive and less susceptible to the discoloration, why would that not be the first line of intervention?
Can I?
Yeah, Pat.
I'll jump in and tackle that. Yep. So awesome question, and it's it is one that we as industry professionals often sort of tinker with. But the important explanation is that the constriction and tuberculation, like let's say the internal corrosion, is the best way to talk about it. That we have detected in Waldwick's pipes is probably too extensive to be stabilized by the typical concentrations of chemical additive that we would recommend, again, as industry professionals. So
essentially our is too advanced for that.
That's kind of the succinct explanation.
Okay.
It will help, but to kind of mimic what we had said in those earlier slides, it helps in the sense that we attempt to sort of optimize the best we can physically before we move on to optimizing chemically.
Okay, and that's just the standard?
It's only the standard in the sense that we'd be happy to recommend that you skip the physical, let's say, flushing, unidirectional flushing, mechanical scraping, and ice picking, if we thought that you could just stabilize with chemical, but we don't believe that it will be effective to simply apply the chemicals. And I want to make sure that we are as plain spoken with you all as customers and users as possible about what we think the best order of operations is for you.
Okay, thank you. That clarifies.
Okay.
Right, next we will have VJ. You should be able to unmute.
Hello, yes, thank you so much for sharing this information. Two-part question. I applaud the idea of the individual who brought up conducting a more extensive subjective survey of the town to make sure we truly reach every town member and understand what they are experiencing to overlay to the work you've already done. The second part and the question, from an objective standpoint, do we test the water when we do our biannual flushing, before flushing and after flushing, to provide more data and information on the actual quality of that water?
I'll take a shot at tackling that question. I think historically we have not, but we recently, in the context of testing, have begun to do so, both for iron, manganese, and for what is characterized in drinking water literature as color. It has its own scale. but it's not in milligrams per liter in the way that dissolved metals or oxidized metals are measured. In addition to that, we're measuring pH. Again, I had mentioned that as sort of what aquatic chemists consider often to be sort of a master variable in your both your raw water at your well stations and in your distributed water, trying to get a sense of how that changes and how we can optimize it. So it has the summary of that is that I don't believe that it has been sampled as part of annual or biannual flushing historically, but now that we're focusing on this as a potentially system-wide problem, we've begun that data collection and analysis.
Thank you.
Yeah, and the Waldwick water pH is relatively what they would consider neutral, as opposed to some aquifers have a very low pH. So then it's a different level of, you have to address it basically from day one to keep it from being an issue with piping. Not so with Waldwick, but certainly going forward with these systems, that would be another part that we would add some monitoring while they're doing that.
All right, thank you. Let's move on to Doug.
Yeah, hi. Doug Nastian here. Just a quick question. Has anybody sent cameras down these lines?
So it's Doug, great question.
Yeah,
Go ahead.
that would tell you what, the insides look like. I know you can get them when you break and stuff like that, and you look at the section of the pipe that you're taking out, you know what your pipe's there. But the other ones that haven't been broken, maybe it'd be a good idea to send a camera down.
So awesome recommendation. And that is generally possible with pipes that are a bit bigger than most of the pipes in your distribution system. Again,
yeah, I understand. I'm coming from a sewer background, so.
Okay, so you know that you can snake a sewer pipe, you can TV it. Little bit of a challenge with tuberculated pipe, especially of the diameters.
I just wanted to throw that idea out there, though.
Definitely a sort of useful tool, and knowing that we're a little bit sort of restricted on our ability to get a reliable camera in these water mains, especially the ones that are remaining in service. We're recommending some selected locations to do couponing, and trying to get the best sort of feedback on what we suspect from our flushing, getting validated with eyes on, and with physical sampling.
All right, does anyone have any other questions? As of right now, I don't see any other hands up. If anyone after this presentation thinks of something, please feel free again to shoot me an email and I will relay that to our team at H2M. This recording was recorded. I'm sorry, this presentation was recorded. So we're going to post this tomorrow along with the presentation slides. So feel free to review, kind of go through it, and reach out with any type of feedback. Again, just a general comment. Reach out and let me know how this went. If you like this format, if you like Teams, if you prefer in person, just want to hear all types of feedback from everybody. And then lastly, I would just like to thank our team at H2M, Pat, Karen, and Bill. Thank you very much. All the mayor and council that were present, and the water quality committee, all of our staff, our water department who's out there every day, actually, boots on the ground, doing all the work, and assisting the team here. So thank you all. Thank you to all the residents. We understand this is a major issue. We're tackling it head on, and we're gonna get the fix for you. So please just continue to be patient, report it, any concerns, questions, comments, and just keep us posted. So thank you all. If no other questions, we'll close things out. All right. Thank you, everyone. Good night.
Thank you.